Thank,
Sorry, go ahead.
thank you everyone for joining on a Saturday morning. I look forward to have a discussion with all of you where I can share my best practices. I can share my learnings throughout my journey. And I hope to have it as an interactive sessions. And please feel free to interrupt me at any point in time. Yes, Nanda was saying that I started my career with Cisco, and I mean, though like all these 17 years I have spent with Cisco, like I have like touched several. I worked across different teams in Cisco. Like I started my career as a test engineer. Um, and then maybe I got bored, and then I spent some time trying automation. Again, got bored, and since my college days, I always had. I always like to code something. I always like to create something. So that's why I decided that maybe I should try some development role. Then I worked on the main data path for the Cisco Secure Firewall, and I have worked on the SNOT modules, which does the basic inspection for the firewall. And currently now I'm working in a module called Encrypted Visibility Engine, which uses machine learning based model to detect threats in the encrypted medium without decryption. This is what I'm working on now. And also, like, I have done my master's in AI with IISc. So there I have learned all the basic math foundation which is required for developing a model. And but most of it may not be relevant now because like we have moved into a world which is like more dominant by large language models. Of course, there are certain use cases where traditional ML models are still required, but most of our current use cases are actually driven by LLMs or SLMs. So for today's sessions, I'm planning to focus more on how the LLMs evolved, the stage that we're currently in, which is like an agentic deployment. We learn about like what are the different security problems that happens when an application becomes like purely agentic and how to secure that. Yeah, let me share my screen now. Mm. So just give me a minute. Is my screen visible now?
Yes, Dinesh.
Oh, yeah. It's good that I got to understand some context about the background from where you all are coming. So probably I might deviate little bit of the content that I have actually planned for. Uh, so basically I want to start with how where we started and how the LLMs evolved and all that. Um, so in 2017, maybe a little bit of context. In 2017, a bunch of Google researchers, they joined together and they published a paper called Attention is All What You Need. That is what changed, uh, that's what like created the LLM moment. So post that research, there are a lot of other ongoing researches that were done on top of that. And only after that, the chat GPT moment came in, that was launched like about in 2022. So we have seen that the number of user base for ChatGPT, it was like the adoption was tremendous. We have never, in our history, we have never seen an adoption like that. It was like exponential. And that was when like even previously we had a lot of chatbots, but then after the ChatGPT movement, we have seen that the number of chatbots increased. There were a lot of customizations being done in the chatbot, and that was the world. I mean, I would say that was the year for like the chatbots and then the different use cases with the LLMs. And after that, maybe 2024 is when the concept of agents picked up, I would say. But 2025 is really the year of agents, and yeah, and it keeps going on. And it's hard to predict like what would be the state of AI maybe 2 years down the lane, because the adoption and then the pace at which it's developing is like tremendous. Every day, new papers. It's very difficult to keep up with the advancements that's happening. But still, I think everyone should make some time and to find out like what are the new advancements. Yeah, of course, it's very tough to like keep up with the pace, but at least at a high level and the areas that we are working on, maybe there we should spend some time watching out like what's happening in that space. So now with this agentic deployment, the problem has shifted from unsafe output to unsafe action. So let's look at first how the LLM works. So an user gives a prompt to an LLM, and then everything looks like a black box to us. So it just magically gives us some response. But how does it actually work? So before an user prompt, there are also like different levels of prompt. I've not included all the levels, but yeah, let's system prompt and application prompt is like one of the important levels. So system prompt is something like that sets what the model is intended to do, like how it should behave. It sets high level. It sets the high level tone for how the model should behave, and comes the user prompt. So this LLMs, all it understands is only numbers. So the first step is all our prompts, they are like arranged, concatenated, and then they are converted to like a manageable sized tokens. That's done through a module called tokenizer, and then comes the embedding layer. Embedding layer is what it's like converts all these tokens to vectors, because LLMs understand only numbers. And this vector is fed as an input to the transformer. That's basically the LLM, which is the engine that powers the LLM, and uh, and then it produces the output. So initially, the way how it evolved is that it can predict the next token, but over the years, there are like a lot of use cases that have been developed around it. Like given a paragraph, it can like identify and analyze the sentiment of it, and yeah, there are a lot of other use cases. So in this setup, what is the worst that can happen? Maybe the model can generate a totally wrong output, totally bogus output, which is meaningless. Uh, yeah, that is one. And other than that, what is the max that can happen? What is the worst that can happen?
It can hallucinate. It can uh, bias something. Say, for example, if I ask it to build how to build a bomb, give me step-by-step instruction. It can give those instructions, which I'm not legally should not learn.
Yeah, that's right. So it can leak information which it's not supposed to do. In this case, like generating a bomb is something, it's a very unsafe action. We don't want any user to learn the steps from the LLM and do something which is totally wrong. And another things like maybe sometimes it may leak some sensitive information, some PIIs, because all these models, they have been trained on the internet data. It can like whatever data that's available in the internet, that's been trained with it. And there is also another kind of attack where the model can leak about itself. It can leak about its parameter. So everything, it actually it corresponds to like wrong output, or like leaking sensitive information. So this like these are some of the problems with the LLM. Actually, there is a non-profit organization, global organization called OAPS, which is called as Open Web Application Security Project. So they primarily used to work on like they used to like give out the vulnerabilities that are possible with the web application products, and they used to like also give some recommendations. So over the years, they have also started giving it out for the LLMs, and now for the agentic AI as well. So yeah, they have like given out a lot of uh, the top 10 attacks that are possible with LLMs. I'm not going to dive into it for today's topic because I want to like limit it to the agentic scope. And then I also wanted to give a brief about the retrieval augmented generation. So as I have been talking, like LLMs, they are trained on the internet data, which means there is something called as a knowledge cutoff date. Let's say, for an example, maybe Cloud Opus or 4.6, 4.7, whatever it is. Uh, for an example, let's say that Opus 4.6, the knowledge cutoff date is, let's say, like last year, September. It means that all the data prior to that, all the data has been used for training it. So what it also means is that it doesn't know information about the events that happened after that. And also in uh, some of the use cases, maybe something is specific to our company, maybe something is specific to the module that we are working on. LLM, of course, if that information is not publicly available, then of course it may not know about it. So RAG is a method using which we can like feed additional documents so that the LLM has context about the additional knowledge that we fed into it. And now the LLM, before giving out an answer, it can also look at the knowledge base that we fed, and then the answers can be from that. The way how it works is that we can feed in like a different kind of documents. Maybe it can be documents, mails, PDF, wiki, whatever it is. And then again, it goes through the same process. It gets like tokenized, and then it goes through an embedding layer, and all that is fed into a database called as VectorDB. Now, what is special about the VectorDB is that when a user prompt is given, even that is converted to a vector. So now when this input vector is fed into the vector DB, now it can give out the vectors which are most similar to the user input vector. So in that way, we will be able to get the context info. I mean, we'll be able to get some context based on the user input, and that context is fed into the model. And now the answers will be based on the input plus the retrieved context. So with this, again, we are opening up the attack surfaces because we are feeding in new documents. Of course, those are the documents that we fed, but what if those documents get poisoned? Then the LLM output is also influenced by the documents that we fed into it. So, here, before feeding any documents into the RAG pipeline, of course, we should do input sanitization to make sure that there's no malicious intent within that. Yeah, this is pretty much the problems that I summarized already. One is the knowledge base poisoning. So if one poison document, or maybe the document, everything looks proper, maybe there is something, a hidden instruction within the document, that is what like poisoning the context. So all that is possible. So before feeding any documents into the RAG pipeline, it should be like properly sanitized. Yeah, previously we all started very immaturely, like having guardrails to check all the intent and all that. But now with LLMs, everything has become sophisticated. Even we can use an LLM to do input sanitization to check the intent of all the document, to even check if there is any hidden instruction or any hidden goldman that is present within the document. Uh, yeah, that is one. And then uh, the other attacks on the RAG is something like, I'm not going to deep dive into all the attacks possible, just the major ones. Something called as an indirect prompt injection. So that is what I meant, like the hidden instructions in the retrieved document. And the next one is the embedding inversion. Embedding inversion is something like, what if we have access, if somehow the vector DB is compromised, or somehow if you're able to compromise the layer so that we are able to like get access to all the embeddings, it is possible to reverse engineer the embeddings to extract the text out of it. So if that is done, then it means that we'll be able to like reconstruct all the documents that we fed into the rack, and we'll also be able to watch out all the user prompts. Yeah, let me just skip through this. Yeah. So now, since we looked at how LLM and RAG works, the way how we can define is that LLM, it can generate. RAG, along with the generation, it can also retrieve the context, and which will influence the generated output. But when we talk about agents, it's like going to the next level. It's like it's complete autonomy. It can generate, it can decide, and it can act. So it's like a complete loop. It can like autonomously take decisions and it can act. So now the untrusted context, it is going to become privileged action in case of agents. Let's look at how the agents work. So agents will still have all the aspects of LLM and the RAG, but the additional things that it has access to is the memory and it has access to tools. What it means is that, previously we would say that maybe, hey Siri, can you check the messages for me? Of course, it will retrieve all the messages and it will read it out for me. Now, with this agentic deployment, we can say, hey Siri, can you check all my messages and respond to it based on my preference? So, which means that you can store your preference, like how you would respond to so and so person for a particular question, and all that preference will be stored in your memory. And then now the agent can actually make a tool call and then reply on your behalf. So in this example, everything you may not really understand the implications. But what if let's imagine we have a trading app which is like completely agentic. So it means that maybe there are like multiple agents. One is doing technical analysis of a particular stock, other one is doing the fundamental analysis of stock, and other one is trying to get the context from both the agents, and based on the information from both the agents, it's able to like make some actual trade. It can decide whether it wants to buy a particular stock or sell some particular stock, which means that it can have access to your bank or maybe your wallet, something like that, and it can actually execute trade on your behalf. So in this particular setting, what if something goes wrong? Your money is in stake. If the agent goes wrong, then it means that it's executing wrong trades, and there is a chance that your money is lost, right? So it all looks scary. Maybe if it's some money you can like earn back, but what about the agentic deployments in healthcare? Some things may be life changing too. All so whenever we go for agentic deployment, maybe it's a trivial use case or maybe it's a very serious use case. Whatever the use case is, we should definitely have some security guardrails in place in order to make sure that all the agentic communication is secure and it's been monitored. So the way the agent gets access to all these tools is through a protocol called MCP. The MCP, it's like more standardized now. So it's like the agent will have access to all the tools and they talk to the tool through this MCP protocol. This is more like for instance, I email is a tool, or maybe database is another tool that the agent wants to access to. So in this case, all the tools they will have a card which will basically give information about what the tool can do and what should be the input schema and what should be the output schema, like what parameters can be fed as input to the tool and what are the output parameters. So it has access to all the information. So based on that, the agent can look at the registry and it can find out like how it can make that connection to the tool and what it can expect out of the tool. And so in this case, there is a single agent. There is also like a multi-agent framework. So in this case, there are like multiple agents that are running together, and agents talk with each other through other protocol, which is called as A2A, that is agent to agent protocol. Yeah, so again, agent to agent protocol that is actually that's proposed by Google, and it's now been widely adopted. Even in case of an agent to agent protocol, like each agent, they will have an agent card, like similar to the tool. The agent card will have information about like what this agent is supposed to do, like a short description of the agent, and then its intended input parameters and then the output parameters. So all this is everything is being there in the registry. So your central agent will contact the registry to know about like what other agents it has access to and what other tools it has access to. Yeah, so let's imagine we have an agent. So there can be like different tools that it can have access to. Like for instance, it can be REST APIs, database. If in case of database, an agent can like query the database, fetch results, and then act based on it. It can be file systems. It can be emails and calendars. So it means that the agent can send emails on your behalf. And agents can execute code, and it can even be like directly making the connection to the cloud infrastructure, deploying SaaS, and yeah, messaging, ticketing. It can be like anything. So every tool that we add, it means that there is an increase in the, we are actually increasing the attack surface. So these are the OWASP top 10 for agentic AI. So I'm going to dive in detail about all of these in the subsequent slides. So before we have any agentic deployment, we should ask ourselves these questions. So the answers to all these questions will help us to plan what are the kind of security measures that are required for this agentic deployment. The first one should be like, does the agent independently plan? Yes. The answer will be yes for most of the agentic deployments, because of course the agent means that it can independently plan. So if it's independently planning, then it means that we are opening up an attack surface, because uh, it can be a wrong. If it's a wrong action, then it might have like serious implications. Does it store memory? If the answer is yes, yeah, of course, most of the answers will be yes. And again, if it's yes, it means that maybe the memory is poisoned. So that is something that we should watch out for. Does it execute tools or code? Yeah. If yes, and again, the problem is that maybe the agent decision was wrong, and because of which if the wrong tools got selected, or maybe the tools executed is not something that then the agent is supposed to execute. Does it authenticate users or service? If yes, then again there is a problem. In case of multiple agents, what if one agent delegates a task to the other? So in that case, if agent B is delegating the task to agent C, let's say, then does agent C run with the permission of agent B or agent C? So these are some of the questions that we should answer before we actually deploy the agentic framework. Other one is, does it involve human oversight? Of course, every agentic deployment, we should have an human oversight, because like we should not let machines decide everything. That can be like totally dangerous. Um, and even with human oversight, there are a lot of issues which we are going to talk about. And if it's a multi-agent system, again, that also opens up the attack surface, because like how do we ensure that agents talk to each other securely? And what if there is a rogue agent because of which the other agents' decisions get influenced? These are some of the things that we should consider. Um, yeah, so prompt-aware kill chain. This is actually a terminology that is framed by Bruce Shiner. Bruce Shiner he's a renowned cryptographer. So what he proposed is that he actually demonstrated that it is possible to like simulate the entire attack vector chain just by using prompts. So that's what he called it as like prompt-aware kill chain. So just with prompts, it is possible to like uh, get it to get some initial access into some system which we are not supposed. The way to do it, there are a lot of ways in which this can be achieved. One is like, uh, for example, if there is some agentic deployment and if it's not properly secured, like if the communication is in plain text, it is possible to like eavesdrop into it, like maybe the man in the middle kind of a thing, and understand what is happening. And there are chances that you'd be able to like get the credentials out of it, and using which so that will help in the initial access part. So all this can be done with just the prompts. How, in the sense, like we can just carefully craft a prompt, which and ask it to like observe the communication in a particular network, and if there is some clear text exchanges, which carries the credentials, uh, we can just ask the agent to like send it out so that those can be used for the initial access. And the next one is like once the initial access is there, then probably we can do some privilege escalation. And then we can like, the next step is like reconnaissance. Reconnaissance is something like getting into the network and then listening to the network to understand like what is going on, to get information about the network traffic, everything. The next step is a persistence. Persistence is like uh, persistence. This kind of attacks is now like becoming very common nowadays. Uh, I just want to, maybe it may be a small diversion, but then I just want to like tell about a different kind of an attack, which is called a salt typhoon. So of late, we have started seeing like a lot of attacks like these, where the attacker, they are dwelling into the victim machine for a very long period. Uh, so it's not like they are like actively doing some communication. They are very silent. They're just passively listening to the system. They keep observing what is happening, and then they are slowly they are moving into other systems. They're doing some lateral movement. Uh, so all the actions are so slow that in our traditional source or the SIM, any observable pipelines, they are not able to like understand what is happening, and they're not able to detect these threats. So we have seen this salt typhoon kind of attacks. The attacker has been dwelling on a system for more than 2 years, and he was silently observing what is happening, and then he was like slowly poisoning the context. So Bruce Skinner, he actually demonstrated this persistent kind of an attack is very much possible just with the prompts. And the next one is the command and control. So once the attacker is there in the victim machine, then like any C to server, it can reach the victim machine and they can like execute command. They can execute command on the victim machine. And the next step is the lateral movement. That means that the attack is slowly spreading onto the other devices in the network. So this is nothing new. This concept is nothing new. This is how the life cycle of any threats will actually look like. But the best thing, I mean, what is new here is that all the stages, it is possible to do all the stages just with the prompts, and everything can be like completely autonomous.
Vignesh, small interruption.
Yeah,
Uh,
sure.
so time first is we are almost halfway through. Um, I want to introduce Hina. Hina is again ex Cisco, and she's right now she's also continue working in leadership role. I wanted to give her 3 to 4 minutes time to pitch her startup, and then give space for her to talk about her initiative and startup, and then post that we'll resume our session.
Yeah,
Hina,
sure.
Thanks,
it's all
Savai.
yours.
Thank you. Thank you so much. Thank you so much, Nanda. We are happy to be associated with Savai. And so thank you so much for giving that 5 minute slot from your intriguing session, Vigneshwari. I just joined and it definitely has taken the attention. So good morning, everyone. I am Hina Seni, co-founder of Beyond Gurukul. We are a career guidance and development organization. You can position us as a career lifecycle partner. When I say career lifecycle partner, what we do is we enable the students, right from students to make the subject choices up to the professionals to take leadership decisions. And how does we do that? When it comes to students starting from 6th standard onwards up till 12th, we help them make the right subject choices by means of our MBTI based psychometric assessment, which assess the students on 6 different parameters, right from their personality, their learning style, career interest, career motivators, and last but not the least, the aptitude combined with emotional intelligence. Because for anything to pursue and get success, our emotions and passions play an equal role apart from our intellect. When it moves to the college goer students or the professionals, we help them build their professional readiness, that how to adapt to the changing world. So far you have been in a stable cocoon of your parents protection or a protected environment. So how get ready for a professional world ahead, whether in terms of your resume, your overall professional appearance, your interview preparedness, dealing with conflicts, whether internal conflicts or the outside world, adapting to change. So we help develop the students on all these soft skills, which are nonetheless the life skills. AI is adventing in our lives, but unless we don't have the change adapting ability, we will not be able to take for the changes what is coming forth. Like as per World Economic Forum, by 2032, almost 86% of the job which exists right now will vanish, and there will be 67 new percentage of the jobs which will be created, which we still don't know. So that kind of change one needs to be prepared for. So we help students in that. When it comes to the professionals, whether you are in mid career, early career, or at CXO level, we help establish your profile, help you in your personal branding via resume, via helping in the career pivoting, which is through our competency assessment. It is a NLP based assessment which assists the individual on 24 different characteristics and patented by Government of India. So it allows you to show the mirror that where you stand in your career, how you can make the progress, and that helps you make your own personal brand. And last but not the least, we are into the training segment, where for teachers we do faculty development program, for professionals we do all kind of life skills, starting from communication, which is not just about speaking English, but how your body language speaks before you start speaking when you enter a room. Right from how you deal with feedback management, how you deal with your emotions, emotion question, anything under the sun, and we take care of it. So I would again thank Savai, headed by Nanda, founded by Nanda, to give us this opportunity to introduce us to all of you. And please feel free to reach out to us in case if you need anything on these different verticals. We are found on beyondgurukul.com. Why Beyond Gurukul? Because something what is covered in Gurukul, we go much beyond that and add that value to your life. So thank you so much, Nanda.
Yeah, thanks, Hina. And I would take very few seconds to talk about Hina. Hina is like a great leader. I worked with her in Cisco. Um, Technical alone will not take you high. It can get you established, but if you want to grow high, soft skills, how you manage the conflict in the organization, how you want to showcase market yourself is extremely important. Without that, you will not scale. And I'm sure with her Hina and her co-founder Rashmi, you'll be able to get that. I believe all of you are working professionals. If you want to scale up, you want to showcase yourself, don't hesitate. Please talk to them and see how you can get utilized. Thanks, Hina, for that. And Vigneshwari, before we resume your presentation, let open up any questions. I'm sure that the kind of people retained that you have a magical in your presentation. That shows, even though I call myself AI security, and then I have noted down a lot of things that I'm not aware of. Thanks for that insight. Um,
Sure.
We'll spend about 3-5 minutes. If anyone has any questions for Vigneshwari before she resumes.
Yeah, maybe while people think about the questions, I just want to address one question, like maybe during our initial talk, I think, or I don't remember, maybe Shinoj. So he was talking about like, even though like he was using AI tools, he faced a problem, like he was in, like there was a testing issue, right? So like the way we generally address those kind of scenarios in our day-to-day work is that the moment we ask AI to generate new code, we also ask AI to generate a test case for it. Of course, it can't like do end-to-end testing. like nowadays with Claude, that's even possible. Like there is a concept called hooks, using which we can actually trigger a script and which can do an end-to-end testing for us. But most of the unit level testing and the functional level testing, it can be that can also be done by the AI itself. Like whenever we ask AI to generate the code, we should also ask AI to generate test cases for it, so that when we keep adding code, we'll also make sure that all the functionalities that has been added before also gets tested. That's how we actually work.
Yeah. You should also explore skills and agent, make it specialized for a specific domain like code review or peer review or a test case builder or executor, and have a dedicated skill or agent which will make. Okay, yeah, someone has the question. Please go ahead.
Okay, thank you, Dan. Thank you, Vigneshwari. So this is a question about how about we have known about that OSAP top 10 A risk what we have already seen in this presentation. So do you guys have already adopted some of the framework where we can promptly respond to the kind of top 10 risk in as an enterprise level?
Yeah, certainly. Yeah, so I'm going to talk about it in the coming slides.
Okay, okay, that's great.
Anyone else has questions?
Yeah, Vigneshwari. So you're talking about the MCP client and all, and MCP client knows what are the tools available, and it knows which tool to reach out to get a task done. I think I've read something called routing as well. So is that does that come under a part of MCP, or is it completely separate? So it knows exactly to which agent to reach out, right? That is what routing does, I guess. So that's what it's going to help us. Rather than spending a lot of time, we don't know which agent to reach out to get a particular task to be done. So
Correct. So in maybe a small deployment, the routing layer or the orchestration layer, that actually takes care of like finding out what is the right agent to pick up. But in a big agentic deployment, we'll have like registries. So that will so any new agent, it has to register to that, so that any new command, it will first look up in the registry to find out like what is the apt agent that needs to be used, or maybe what's the appropriate tool that needs to be invoked to do a particular action. Yeah, but actually what you're saying is very similar to the registry.
okay. So that as a user, as a developer, when I try to bring up building up an agent, so I need to keep that in mind, and I need to configure it properly, right? For example,
Right.
you might come up with plenty of tools, right? And it will end up in keep on searching which tool to use it. We might lose out some time or something. So this would be critical.
Yeah, actually, you have brought out a very important point. So I have seen some use cases where like people had like maybe 60, 70 tools. So each time the agent, any new prompt, it has to like look through all the 60, 70 different tools and find out like what is the right tool. So that will of course add to the latency. The way to solve it is that it's possible to like do some add some hierarchy layer to that. For example, if it's anything related to probably like terminal commands, maybe you just have to look up maybe some terminal tools. We can add some hierarchy, and then we can say that anything related to terminal tools can probably look at only the tools that are there under that hierarchy. Maybe we can do some layering on top of it, so that we don't spend a lot of time going through the entire tool list.
Okay.
Thanks, Vishri. I think there are some appreciation coming already. Any best practices, frameworks, and resource to keep up with changing AI tech?
Best practices, I would say, like keep looking at like technical blogs. So if you're someone who is interested in research, maybe like keeping a tab on the archive articles, that will help. But if you're someone who just needs to know about the different frameworks, then probably the best place to check is something I would call like we do have a lot of people post a lot of things in Medium or even in a lot of other technical blog posts. So those are the things I would say that you can watch out for.
Cool. Thanks. So in the interest of time, we have 15 minutes. I hope you'll be able to wrap it up. Vignesh. Again, once again, behalf of everyone, Vignesh, thank you. And one of the session where I see that people who have joined still retain, there's close to zero drop of people. Please continue.
Yeah, thank you. Let me proceed. Is my slideshow visible?
Yes, visible.
Oh, okay. Yeah. Okay. So let's look at the core vulnerability classes. We can like divide it into like different classes. So the first layer is the input layer itself. So in the input layer, like what are the things that can be fed as an input? It can be like a user prompt, and then the context poisoning that can be because of a rack pipeline, or it can be because of the user prompts only. Like every time there is an user prompt, right? That also gets stored in the memory because agent has access to memory. So it gets stored in the memory. So again, there can be some context poisoning because of this. So the way to solve that is that we can put up a filter there. Like any new untrusted input has to be fed into that filter. That filter can be anything. It can be as simple as a guardrail, which can just mention like okay, these are the things that you should watch out for. Maybe if there is a credit card information, or maybe if it is leaking username, password, or something like that, then block those kind of inputs. It can be as simple as that. But yeah, of course, in a small agentic deployment, this might be sufficient. But if we have to like scale it up, this may not be sufficient. So we can even use LLM to find out the intent of the prompt. If something is malicious, then that can be blocked. There are a lot of players now. We have a new concept now. We have seen network firewalls before, but now we also have a concept of AI firewall. This is exactly that. So every input to the agent is first, it has to first go through the AI firewall or AI gateway, which will actually check the intent of the communication, if something is malicious or not, or if there is some hidden instruction that is embedded, and then it can decide like whether to allow the prompt or not. That's the kind of protection that we can add in this layer. And the next layer is the execution layer. That is where we get to call the different tools, or the code gets executed, or it can be even the supply chain attacks, like new agent, new tool being onboarded, all that. So in this case, how can this layer be secured is that we can have a policy enforcement framework. So this framework, this will actually kind of make sure that, okay, this tool is authorized to perform this action. So maybe the next layer is also like they both work in conjunction, which is the identity layer. So before we kind of enforce, okay, this tool is allowed to be called, then we should also determine like what is the identity, like what is this agent? Why is this agent calling this particular tool? Is this agent actually allowed to call the tool? So these are some of the questions that needs to be addressed. Let me take the example of that trading app itself. Like as I was saying, that we have like different agents now. Like one is doing technical analysis, other one is just doing the financial, like if evaluating it from the like valuation standpoint of view, and the other one is actually taking the action. So the maybe let's say the master agent. It first reaches out the technical analysis agent to get out what it thinks about a particular stock. And then it probably also gets the fundamental analysis, and then it actually executes the trade, right? So now when it actually executes the trade, do we know that it is the agent which is executing the trade? If yes, how is that logged? So which means that we should give an identity for each of the agents. So maybe the master agent is trying to like make the trade, but that was not the one who decided to make the trade, right? It got all the inputs from different other agents. So all the actions needs to be logged. It should be very clear. In fact, if something goes wrong, it should be possible to go back and learn, like, okay, which agent influenced the other agent's decision. It should be possible to know. So which means that we should have like definite identity even for agents. Identity for humans is not enough. We should have identity, separate identity even for agents. That is very important. And the other one is the inter-agent communication. So all the communication between the agents, it has to be secure. So actually the standards, they propose to use MTLS, that is mutual TLS. So traditionally, we have seen that just the servers client will validate just the server identity using the certificates. But in case of NTLS, both the sites need to verify their identity. So that is what they recommend for even the inter-agent communication. So mutual TLS should be used. And even in case of rogue agents, if we have an identity in place and if we have an enforcement layer, then it is very easy to find out if there is a rogue agent that is there in the place. Even maybe initially when our agent got onboarded, it's doing what it is intended to do. But maybe slowly down the lane, its goal got hijacked and it is misbehaving. So when such things are happening, again, the input layer will help us, because every new prompt is being fed into the AI firewall. It actually checks the intent of the communication. So there it gets caught. So I'm just going to dive a little bit deep. Maybe in the interest of time, I have to go fast. Let me try to cover as much as possible. Yeah, the first one is the memory poisoning. So like each time when we feed the input, it gets stored in the memory store. Yeah, in an agentic framework, we have both the short-term memory and the long-term memory. If there is no distinction between both the memory, then there is a chance of an attack, because maybe first time I am asking an agent to do something else, and then I log out. Some other user logs in, then maybe my decision will also influence the next person who is logging after me the if the context cleaning is not done properly. So in the agent's memory, it should be cleaned whenever a new user logs in. So all that has to be done. Otherwise, my decision will influence the next person's decision. So all that has to be avoided. Okay, so imagine I'm an attacker. I'm injecting some false data, and because of which my memory got corrupted. That means that my agent will start doing something which it is not supposed to do. But if I have an AI firewall in place, all this can be avoided in the first place itself. The next one is the cascading hallucination. Okay, let's say my agent memory got poisoned. Now what happens? So now my agent thinks that based on the poison constant, it thinks that what it is doing is right. So what happens is that at each iteration, it believes more and more that what it is doing is right, and so the wrong output is going to be amplified with each iteration. And imagine with a single agent, it is just the single agent which is trying to reinforce itself, saying that, okay, what I'm doing is right. But in case of a multi-agent scenario, because agent A believed something which is not supposed to do, it will also be influencing other agents. So that's like all the poisoned context that's been fed into agent A, you are seeing the cascading effect. It's been pushed to every other agents that's there in that pipeline. Okay, this is a very interesting problem. Human in the loop. A lot of times we say that, okay, there should be human in loop who has to approve a certain action. But this has also created problems. Personally, I myself I had a problem because of this. So I was working on a project. So that was like a totally new thing. I have to totally new research project. And I have been working like almost like 6-7 hours. So each time I was actually using Claude. It was asking for my approval. after a certain point of time, I just got so exhausted. Like I started trusting that the Claude, whatever Claude generates, it is genuine and it's all good. Because that's how it was actually. All 4 5 hours, whatever it was seeing, everything looked right. So after some point, I started clicking on OK. It asked me like, should I do this? Should I do this? I started clicking OK, instead of actually paying attention to the question. So after a while, I don't know what happened, but I think there was some confusion, and it asked me like, should I do git reset? I accidentally clicked OK. So it means whatever changes that I have been doing the whole day, everything it went out. Everything got destroyed. It was not able to actually retrieve. When I asked Cloud again, it was like, "Oh, I'm sorry, I'll try to retrieve it." But unfortunately, it could not retrieve. It could not actually retrieve from its own context, and yeah, all the data got lost, and I have to redo it from the beginning.
So Vignesh, it reminds me. I use Cloud Code a lot, and then it keeps asking me. I mean, it's a fatigue, right?
Yeah,
Consistently works, and then we do auto approve. I don't even click it. I say like there is a auto approve mode. You just enable it so that it doesn't even ask you anything. It can keep continue working on it. This this definitely reminds how dangerous it is. Yeah, thanks for sharing that experience.
yeah.
Please
So
continue.
in my case, I just lost one day of my work. But another teammate of mine, he accidentally deleted the entire database. Yeah, things like this also can happen, which is like very dangerous. So that's why like we should know like how much how much of a control we should give. Maybe like if something is very trivial, then probably we should ask Cloud not to ask for human approval. So
Mm.
there should be like a bounded autonomy. Uh, we should have rules defined, like okay, maybe for something trivial, human approval is not required. Maybe for some approvals which requires like touching the database, maybe read is fine, maybe a write human approval is required. So we should
Mm.
have rules set up like that, so that we can avoid fatigues like this.
Cool.
Yeah, I think even I like to share my experience, right? So even
Yeah,
I'm using GitHub Copilot, that is IDE. I don't know what mode you are using, like CLI or something. So in my case, like as you said, right, I started trusting like it does all this complicated job, so I completely have a faith on it, and I just keep on clicking OK. So when it is doing the reasoning part, right, it is giving actually complete information, but sometimes maybe we are time constrained, or like we are careless, we are not going through what it is exactly doing it. Maybe if you have caught it at that point, maybe we can say no, this is the way I need it, but you are doing it the other way. Maybe we can correct it. But sometimes we fail to completely go through the reasoning, and then or sometimes it disappears and comes with a conclusion, this is what I'm going to do next step. So without knowing the complete reasoning part, maybe I click OK, then it will go in other way, right?
yeah,
So I don't know, like even I face that sometimes, so I'm trying to figuring
So,
it out
Sa-
too.
so Satish, the fatigue of giving okay is human thing. It is going to happen, no
Mm,
matter what you do. So the alternate to what you're probably talking is like when you start the project, at least I don't know about IDE environment. When you do work on Claude code, there is Claude.md file which you go and reinforce what your entire project is all about,
mm, mm,
and
mm, mm.
then what is the exact output, and whatever the big sheet talking about, things that it can auto approve, things it needs an definite approval, everything you can go and define it.
Got it.
If you reinforce those things, no, it will be properly guided.
Mm, mm, mm.
yeah, exactly. If you're working with a Claude CLI, then Claude.md makes sense. Otherwise, like with the IDE or maybe Codex, they use agents.md. So depending upon like what models you use, like we have to set up those files, like either it's
Okay.
Claude.md or agents.md, and we have to clearly define our intent. Okay,
Okay.
this is
Mm.
what I need to achieve, and these are my constraints, which needs to be followed whenever something new is being done, and maybe trust criteria also, like these are the things, these are the bare minimal things which we should make sure that it should work at any point of time.
Okay, it's this plot.md file and whatever the other file that she talked about is the system prompt for every prompt that you're going to send. Okay, somebody's saying that Manu has to drop. Okay, sorry, Vignesh, go ahead, and then we are on top of the us.
Yeah, I'll just closely complete this. So maybe I'll just skip this at that. Yeah, so I will just not
Okay.
talk about this.
So Vignesh, I think few people are asking if we can continue beyond 12, or you want to reschedule, have one more follow-up session on this. Or how do you want to do?
Yeah, I think I have a lot to cover. Maybe a follow-up session is also fine.
Yeah. So I think this is definitely. I feel proud of myself that I know many things on the AI, but Vignesh came and shattered it. Thanks to our in-depth knowledge. I think we can have follow-up sessions and then go deep dive. I personally would want to do it. Yes, follow-up session demo. So yeah, I've given a WhatsApp link. Please do join that link. And what are the upcoming sessions? I'm going to post it there so that you'll be able to join it. Okay. So in the interest of time, Vigneshwari, will wind up. We'll stick to the time. Okay. Anything that you want to last, something you want to talk and before winding up?
Yeah, so actually I pretty much covered all the problems that can happen with the agentic deployments, but I'm not really went into like how can we secure this. Maybe I little bit touched about the AI firewall, but yeah, and maybe probably in the next session I want to go deep into that, and also like maybe before the next session, if you people have something in mind, then probably if you can like pass it on, then I can also plan content around it.
Cool. Yeah, I will just open up for questions. If anyone has any questions for Vigneshwari, please ask. So,
not a question, but just wanted to say thanks. This is helping understand all these complex terminologies, and everything was extremely complex. Now it's simplified a lot. So thanks a lot. Just wanted to check if we can get a recording of this session. I had to miss the first 10 minutes. So just wanted to check that.
Yeah, Lakshmi, we'll post it on the YouTube. I'll just specify that YouTube link also. Man, you have joined. I'll share the YouTube channel link.
Okay.
It'll be posted in within a day.
Okay, thanks a lot.
Okay.
Thank you, Lakshmi.
So everyone, please join the WhatsApp group so that we will keep sharing all the latest session that is happening. I've just shared the YouTube link, YouTube channel link that you'll be able to check the entire video. Any other questions to Vigneshwari? Hey, Vigneshwari, thank you so much. This is one of the session where the retention of the people is strong till last more, if not all of them were stayed on the call. Thank you so much.
Yeah, thank you. It's my pleasure. Yeah, looking forward to talk to you all again.
Okay, thank you so much, and we'll be happy to have you all in the next follow-up session as well. Thank you, everyone. Have a nice day.
Yeah, thanks, Nanda. Thanks, Vigneshwar.